Okay, good morning. If you have any questions, just ask me. Am I audible? Am I audible? Hello?
Yes, sir.
Okay.
Yes.
Yes,
If
sir.
you have, if you have any questions, just let me know. No questions? Okay, then I will start. Okay, so in the last lecture, I discussed about three different type of elementary reactions. One is this consecutive reaction, then second is parallel, and third is reversible. And we also looked at how to get rate constant. Consecutive reactions are very important in the sense that most of the complex reactions involve consecutive reactions. And there are two very important points I discussed. One is uh, that slow step, the rate determining step, and second is that we can apply steady state approximation if slow step is followed by fast step, or in other sense, if amount of intermediate remains very low with respect to reactant, concentration of reactant and concentration of reactant and concentration of uh, concentration of reactant and concentration of product. So that was two very important point. Uh, use of steady state approximation is that we don't have to solve your differential equation. Okay. So now let us go, and we already discussed the reversible reactions. And we showed that this the kinetics of consumption of A can be written as a first order reaction where the rate constant is rate constant of forward reaction plus rate constant of reverse reaction. And this is how the reactant concentration will look like with time. And then if we plot ln A minus A equilibrium versus time, we will get slope which is equal to minus K1 plus K minus 1. If we can measure K equilibrium, then we can calculate the value of K1 and K minus 1. And then I discussed about somewhat complex reaction, for example, A plus B going to C, and then I discussed how to obtain this K2 and K minus 1 value. You can flood uh, this reaction with greater amount of B so that the change in B is negligible with respect to its initial concentration. And in that case, we can get the value of K2 and K minus 1. This I have already discussed. And if you remember that K observed will be equal to K1 plus K minus 1, which is equal to K2 B naught plus K minus 1. And since we know the initial concentration, so we have only two unknowns, and so we can we can know the value of K1 and K minus 1. Then I started discussing about complex reactions, complex, you know, uh, reactions where K1 and K2 may not be neglected. Different rate constant cannot be neglected. In that case, we need to solve differential equation, and sometimes it is very complex differential equation. In that case, we don't have any choice but go for numerical analysis. And I discussed that how numerical analysis is important. Any scientific programming which we want to do requires the use of numerical analysis. And what now I am going to discuss is one of the method that is known as RK method, which is generally used to solve differential equation. So for example, this is second order RK method, and this is quite often used to solve the differential equation. So this is your differential equation. Dy by dx is equal to function of x and y. In that case, in our case, generally we are looking at dc by dt, or deconcentration of reactant by dt, or deconcentration of product by dt. So in that case, concentration will be y and t will be x. And this function should be with respect to x and y. In that case, this is given y1 is equal to y naught plus half k1 plus k2. So what is k1? Y1 is the, you see, y0 is basically, y0 is y at x is equal to 0. Or in that case, y0 will be concentration of C at time t is equal to 0. Time t is equal to 0, which we generally know. So y0 we know. And k1 is k1 plus hf0. So this function at time t is equal to 0, what is the value of that will give you, means at x is equal to 0 in this particular case, that will give the value of f0. So k1 is equal to hf0, and h we generally calculate. I will discuss in the next slide. And then k2 is h is equal to x0 plus h plus y0 plus k. We know the value of x0. For example, here, please mute yourself. Yeah. So x0 is value of x, value of t, which is 0. In this case, if you know the concentration at t is equal to 0, so that is x0 value. T basically this will be 0 because t is equal to 0, and y0 is value of concentration at time t is equal to 0. Okay, and k here, k is basically k1. This should be k1. And so only thing we need to know h. I will explain in next slide what I mean by that. So let us think about one different case. Dy by dx is equal to y minus x. Suppose this differential equation you need to see. And you know that y at 0 is equal to 2. Okay, y at 0 is equal to 2. So first we need to calculate k1. And k1 is, if you remember, k1 is, what is that? K1 is h into f0. H into f0.
Sir,
So
K2
this
should be h into f. Sir, K2 should be h into f of x0 plus h and y0 plus k1, right?
Yeah, here. Okay, k2 is equal to h into x0 plus h.
Sir, it should
y
be f of x0 plus h, right?
Okay, you are right. Yeah, I'm sorry. There should be f here. Yeah, you are right. Okay, so h into function of x0 plus h, y0 plus k1. And this is basically f0 is function of 0, x is equal to 0, and y is equal to y0. Is this okay? So now let's see one example. Y0 is given 2, and suppose I want to calculate y 0.1. Okay, so we can go into several different ways. but let's take h is equal to 0.1. If I take x is equal to 0.1, I will get the value of y at 0.1. So 0.1 is the next time, time, if we go in the kinetics thing. Okay, if we are solving dc by dt is equal to this. In this case, this will be h is basically 0 plus why we don't say x, I will discuss that. But right now, if I suppose want to calculate y at x is equal to 0.1 and I want to go through one step, then I just put h is equal to 0.1. So now if I take h is equal to 0.1, the k1 value will be h into f naught. What is f naught? F naught is y at 0 minus x, 0. So 0.1 into 2, 0.2. Is this okay? Is it clear? What I told, that k1 will be h into f naught. What is f naught? F naught will be, y at 0 value, which is given 2, and x is 0, so 2 minus 0 is 0.2. So this is the way we calculate the value of k1. Now k2. If you remember k2, what was the k2? H function of x naught plus h. What h we have taken? 0.1. So x0 is 0. So 0 plus 0.1 is 0.1, and y naught plus k1. So y naught we know, y naught is 2 and k1 is 0.2. So 2 plus 0.2 is equal to 2.2. All right. So h multiplied by function x naught plus h, comma y naught plus h. So 0.1, 2.2. And now we can solve this function. This is equal to y minus x. And so it is 0.1 into y is what? 2.2. X is 0.1. So 2.2 minus 0.1 is 2.1, 0.21. And now once we know that, we know y is equal to, y1 is equal to y0 plus half k1 plus k2. Am I right? So y naught we already know. So that's what we have done this. Y 0.1 is equal to y0 plus half, and then k1 plus k2. So k1 plus k2 is 0.2 plus 0. This is 0.2 and this is 0.21. So this is your 2 plus half into 0.41. So this is y at 0.5 value. Okay. So there are two ways. This is one of the simplest way that I took h is same as the y value, means y need to be calculated at x is equal to 0.1, and I took h is equal to 0.1. All right. But we can also go in a different way. We can take h is equal to 0.5, 0.05. Then I can do in two steps. So first I will calculate y 0.05, and then I will calculate y is equal to 0.1. Same way, so several iteration we can do. As if we go lower and lower value, for example, I can start with 0.01, h is equal to 0.01. Then I have to do this 10 times to get y at x is equal to 0.1. The more number of steps, the more accurate value of y you can get. Okay, more accurate value of y you can get. And now you see this all differential equation. What we are trying to do? Only positive multiplication. So these are the only thing we are doing which computer understands. And iteration it can do very fast. And so very accurate calculation or value of y at 0.1 can be obtained. So that is beauty of numerical analysis, because it gives you a tool to solve differential equation or integration or roots of equation in terms of only plus minus multiplication and division. And that's why in scientific programming, if you are interested in scientific programming, then you must study the numerical analysis. Okay, any question here?
Sir, by this method, are we trying to calculate the concentration at different times?
Yeah, that we can do. In this question, what we have calculated, y at x is equal to 0.1. But same thing we can do in kinetics. So dc by dt, am I right? Or dA by dt. So C will be y. So what will be the concentration at a given time that you can calculate? Okay. So then you can go and do the fitting and you can know the value of K1 or rate constant. Anything else? For example, if A going to product, so what I will write, minus dA by dt is equal to K1 into A. Am I right? K into A. So I can know what is means I can calculate for different value of K what will be the A with respect to time. And then we can just fit our data. Whatever we got A with respect to time, just you fit it, then you can go and get the value of K. So there are two ways. So this is the way. If suppose I don't have like a luxury of plotting, like some parameter versus t to means which gives slope, and from slope you can calculate rate constant, and that cannot be done for complex reaction. But I can write the differential equation. Am I right? And if I can write the differential equation, then we can solve it. Hello? Yeah, so we can solve it. And we can in fact fit our experimental data with the simulated data to get the rate constant. Is this clear? Is this method you can understand or not? Do you want to practice right now?
Yes, sir.
I can give you time. So just do yourself without, I will just open the, let me see. Okay, so here I have given you the equations. You try yourself first. Write this differential equation, dy by dx is equal to y minus x. Please write this.
Sir, in this we have assumed h to be 0.1, right?
Yes.
Okay, sir.
So why we assume? Because I want to calculate y at 0.1. So I thought, okay, just for making it more simple, because I am not using, we are not using, like computational programming here. I assume that h is equal to 0.1. Okay. So in one step, I can get the value of y at 0.1, which may not be accurate. The way we can go is, suppose I take h is equal to 0.01. So first I will get y at 0.01, then y at 0.02, y at 0.03, y at 0.04, and then in 10 step I can get y at 0.1. Okay. Here I showed you one step, but in 10 step you can do through iteration by writing a computational program. If you know a computational programming, then you can yourself write a simple program. Only thing you need to know this method. Is this okay? Just try once. If there is any problem in any step, just let me know. सभी ट्राई कर रहे हो या नहीं? Please try yourself. Okay, great. F naught is basically f at x naught and y naught. Are you guys done? Just do in one step only. Take h is equal to 0.1 and then do it. Please let me know when you are done.
Sir, like in this example, it is forming linear differential equation also. But is there any example that which is not forming linear differential equation and it can solve?
Yeah, we can write several, equation depending on the mechanism. I will show you how to write the equation. I will not, and then some of the complex equations which has been used. I will show you how to write the differential equation, and then you can yourself understand it is quite complex. And sometime you will also get two differential equation which can be solved simultaneously. So for that also I will discuss. Okay.
Okay, sir.
So can this method be used to compute y at large values like y of 100 or y of 1000?
You can always do that, but in that case, so it depends. If you are going for y at 1000, so then probably h will 10 will be okay. So it all depends on at what value you want to calculate.
Yes.
Okay. So in that case, interval maybe a small interval will also work. Means a big interval in comparison to what we are saying 0.1, it will also work. So choosing a h value will also depends on, for example, you can make it shorter and shorter, but you find out that uh, suppose from going from 0.1 to 0.2, there is not much change. Means if you are going into two step and one step, then you realize that maybe point 0.1 may not be good enough. Point 0.1, you are wasting time. You can go h with 0.2. So you have to see all those things. It is not that easy, but means like if you can go in 10,000 step, there is no problem because computer will do it for you, right? And it doesn't take much time. Okay. So
Yes, sir.
it doesn't matter if you go for very small time interval. For us, maybe 10 step to 100 step doing ourselves will take a lot of time, but for computer, it will not take that much time.
Hello, sir. Hello, sir.
Yes, yes, Nikita, tell
Sir,
me.
suppose we are doing it in 10 steps by assuming h is equals to 0.01. Then, sir, in
Yeah,
the second step, y is equals to y at 0.1 plus half k1 dash plus k2 dash. Sir, what is k1 dash? मतलब की value कैसे
then
change होगी?
again, say same thing you have to do. So let me go to, okay. So for example, here K1 will be equal to H into F initial value. Initial value can be 0.01. Am I right? So now you are starting with initial value because you know the y value at 0.1. So basically you can do like this. If you can write f1 or f 0.01, am I right? And then in that case f this will be, sorry, function of, yeah, okay, function of y at 0.1 or x at x is equal to 0.01 and y at 0.01. That you already know, am I right?
Sir.
Yeah, so that will be the value of k1. And k2 will be h, function of x naught will be equal to 0.01 plus 0.01, right? Because h is 0.01. So this will be 0.02. And y naught, now I will take x, y at 0.01 plus k1 you have calculated. Is this okay? Do you
Yes,
understand?
sir. Yes, sir.
Okay. So this is initial value. Initial value now you are taking at x is equal to 0.01. So y will be certainly y at 0.01. So then you will in second step you will get value of y at 0.02. Am I right? And then again you go and calculate for y at 0.03. But then you use here k1 is equal to h will not change, am I right? 0.01 only.
Yes,
But
sir.
now f0 will be different. Now we will take f at t is equal to 0.02. Okay. Is this okay?
Yes, sir.
Means if you know how to do this, you can start means writing program. If you know C++ or any other language, you can means very easily write a program uh, to solve this equation at least. Is this okay? Can I go ahead?
Yes, sir.
Anyone, if anyone has question, please stop me. Otherwise, I will go ahead and tell you more complex methods. So this is simple equation which is called second order RK method. But there are other equations also, like this is fourth order.
Sir,
Yeah, please.
sir, in the previous slide, we have to calculate K1 and K2 separately for each step in the iteration. Huh?
Yes.
Okay.
Yes. Okay. So fourth order, method. Fourth order method, it is quite same. Here it is written x plus delta x, which is basically h value, and this is your 1/6. Only thing you have to keep in mind here. So in this, delta x is h. Okay, delta x is h, and here ux is basically y. Ux, it is written du by dx, and here u written, u is basically y. So dy by dx or du by dx. So x and u function, then you have to calculate 4k, and that's why it is called fourth order. Okay, 4k values, and based on that you can calculate same way, it goes same way. So please keep that thing in mind. It is not much different. Only thing is that you are doing